All right, so we are continuing on to Chapter 8. We're now moving on to Section F. After this, we will only have one more section left to cover. And this is just going to be simply graphing lines from equations. So you will be given an equation and you have to graph it. All right, and then there are two ways that you can graph this. You can use it or graph it in slope-intercept form. And then you can also graph using the x and y intercepts. And if you're going to use this way of graphing, you most likely will use your standard form. All right, so you can graph it in either form, standard form or in your slope-intercept form, and we'll go over both ways. And then you also have to know how to graph vertical and horizontal lines. And those ones, it's not really a form that you use, but it's just really easy. And we can go through how you can actually use your standard form to graph a vertical or a horizontal line. But those ones will just be mainly just a discussion that we do. All right, so let's go ahead and talk about the different forms again and how we can graph in each form. All right, so when we are solving using slope or gradient-intercept form, remember we're using the form y is equal to mx plus b. And then there are two letters that we need to know. We need to know our m and we need to know our b. Remember, our m is our slope, and our slope is our change in y over change in x. Right, something that we've talked about in detail now for a little bit. And remembering it in this way, change in y over change in x, will make graphing your slope very easy. So this is important that you understand what this means, change in y over change in x, or vertical change over horizontal change. All right, so the first letter you need to know is m, and that's our slope. And then the second letter, and we've already talked about this in class, and that is our b, which is our y-intercept. And remember, this tells us where our graph crosses the y-axis, right? The y-intercept tells us where we cross the y-axis, right? So it's incredibly important that we know what these two numbers are, and that's all we need in order for us to graph. Right now, before we start graphing anything, we'll go over some examples of y-intercepts. So if we got y is equal to x plus 1, so this plus 1 tells us that we are crossing our y-axis at a positive 1. So this y-intercept is here at 0, 1, because remember, as we move up on our y-axis, we're moving in a positive direction. And as we're moving down on our y-axis, we're moving in a negative direction. All right, so if it was y is equal to x plus 1, our point will be here at positive 1. So we start from our origin where our two axes intersect, and we just move up our y-axis to that positive 1. If I gave you y is equal to 2/3 x minus 4. So this minus 4 tells us our y-intercept is that negative 4. So we'd start at the 0, 0, and we'd count down 1, 2, 3, 4. All right, being able to do this is extremely important for you to be able to graph. All right, we're going to go through an example now, which the first step is using this y-intercept, and then the second step is going to be graphing our slope. All right, so you're given the equation y is equal to negative 3 over 4x plus 5. So remember, our slope-intercept form is y is equal to mx plus b. So what we need to solve for is what is our m and what is our b? Well, our m, our slope, is whatever is being multiplied to our x. It's whatever is being done to our x variable. So in this case, it is being multiplied by this negative 3 over 4. So our slope is equal to negative 3 over 4. Let me change the color of this b. And then we need to solve for our b. Our b is whatever is being added or subtracted to our variable. And whatever sign we have, that's part of our y-intercept. So this is a positive 5. That means our b is also a positive 5. All right, so make sure whatever sign is there, if it's negative, your answer will be a negative for that part. All right, now, just like what we talked about in the last video, the first thing that we are going to graph is we are going to first graph our y-intercept. That's what we start with first. So here's our origin where our two axes intersect. And if we're moving where b is 5, we need to move up 5 spaces. So 1, 2, 3, 4, 5. All right, so here is my y-intercept. Right, now, in order for me to graph a line, there is a theorem that we have in geometry, and that is that all you need in order to graph a line is you need 2 points. If you can have 2 points, then you can graph a line going through those 2 points. So what we need to do now is we will then use this slope in order for us to generate our second point. So remember, our slope is our change in y over our change in x. So what we need to do here is say, what is our y changing? Well, it's saying it's -3. So my change in y is going to go -3, which means we are moving down 3 spaces. Because as we're moving y up, it's positive. As we move y down, it's negative. So I'm going down 1, 2, 3. So I know that my next point is going to fall somewhere on this line because we know that our change in y was at -3. Right? Then I look at my change in x. And my change in x here says a +4. So my change in x is equal to +4. So remember, as we're moving positive for x, we're moving to the right. So that means my next point will be 4 spaces to the right. 1, 2, 3, 1, 2, 3, 4. So here is my next point. And once I draw these 2 points, I can then go ahead and I can graph a line going through these 2 points, because one theorem that we have in geometry is through any 2 points, you can draw, or I can draw a line. So let me just go ahead and draw this real quick. All right, now you will use a ruler in class, but right now I was trying to find a ruler that I can use for a straight edge, and everything I had was making it difficult for me to use the writing pad with this straight edge. All right, but now you see I drew a line that was connecting those 2 points, and I went and I continued my line. So that's why you'll use a ruler, because you can use that straight edge to just make it a really easy line. And you continue it, and we put the arrows on the end saying that it will go to infinity. Right? And if we wanted to, we can check another point. We can see, well, where will our next point be using this slope? We can count down 1, 2, 3, and to the right 4. 1, 2, 3, 4. Now, obviously, my straight edge here, I didn't have one, so it didn't go through it exactly. But that's where my next point would be, and we can use our slope to generate a third or a fourth point if we really wanted to. But all you need in order to graph a line is 2 points. All right, so that's using our slope-intercept form. All right, now the next way that we can graph a line is in our general or our standard form. So remember, we can graph in this form as well. If you want to and you prefer the other form, I don't care how you do it, because the question will just say graph. You can use any of the forms you want. Sometimes we'll talk about why it's when it's easier to use the standard form, and when it may be a little bit more challenging to use the standard form. But I don't really care which way you do it, because you'll get the same graph. But we talked about before what x and y intercepts are. So we have in a graph an x, in a linear graph, we'll have an x-intercept, and we'll have a y-intercept, right? And we talked about in our last graph that we did, our y-intercepts we know is where a graph crosses this y-axis. So if I pick this point here, and I ask you, what is my ordered pair for this y-intercept? Well, our x value didn't move, so it will be 0, and our y value went up 3, so our y-intercept will be 0, 3. If I asked you, what is our y-intercept for this graph, this point? Well, here our x didn't move, so we know it's going to be the point 0, and our y went down 2, so it's going to be the point 0, -2. So one of the things that you can notice for this is when we have our y-intercept, our x value is always, always, always going to be 0. And then we will have our y value for whatever our y-intercept is, right? So no matter where I put this point on this y-axis, we never moved anywhere left or right from the origin, so our x value is 0. So our y-intercept, our x value, is always going to be equal to 0. Our x value is equal to 0. All right, now if we look at our x-intercept, if I put this point here, that's where it crosses our x-axis. Well, if we look, we didn't move anywhere up or down, so if I ask for my ordered pair here, all I'm doing is moving to the right, 1, 2, 3, 4 for my x, so this will be the point 4, 0. If I put the point here, I didn't move anywhere up or down, so this point is just 2 to the left for x, so that's -2, and then our point for y is 0. We didn't move up or down at all. So if you notice, with our x-axis, or x-intercept, our y value is always equal to 0, so the ordered pair that we have here is x, 0, or y value is equal to 0. And this is 2 very, very important things. When we have our x-intercept, our y value is 0. When we have our y-intercept, our x value is 0. And that's what you need to remember. So when we're graphing from standard form or general form, you need to know and be able to solve for your x-intercept and your y-intercept. And we do that by setting the other variable equal to 0, meaning when it's our x-intercept, our y value is 0. When it's our y-intercept, our x value is 0. All right, so let's go ahead and do a problem really quick of using this form. So if you're asked to graph an equation in standard form, what you need to do, because remember, as we said in the last question, all we need are 2 points. If we can get 2 points, then we can graph a line. That's all you need in order to graph a line. So we are going to solve for 2 points that we just went through, our x-intercept, and we'll solve for our y-intercept. And as we talked about, no matter where we are on our x-axis, we know our y value is going to be equal to 0 because it never went up or down. So when we have our x-intercept, we simply just set y is equal to 0. So that means we can substitute in 4 times x minus 3 times 0 is equal to 12. So we simply just substitute in 0 in for y, and that will solve for our x-intercept. Well, negative 3 times 0 is 0, so we're left with 4x is equal to 12. Then we divide each side by 4. X is equal to 3. So that means we have the point 3, 0 as our x-intercept. So I will go over 1, 2, 3. There's my point, and I graphed my x-intercept. Now for my y-intercept, just like we talked about, our x value doesn't change from our origin. When we move up and down our y, we didn't move anywhere left or right. So our x value is always 0. So that means we set x equal to 0. So to solve for a y-intercept, it becomes 4 times 0 minus 3 times y is equal to 12. Well, 4 times 0 is 0, so negative 3y is equal to 12. We divide each side by negative 3. Y is equal to negative 4. So our point for this one will be 0, negative 4. So we'll count down 1, 2, 3, 4. There is our point for our y-intercept. Once I have 2 points, I can go ahead and draw my line going through these 2 points. You would use a straight edge to draw this graph. And there's our graph. We're done. All right, and now we can use this graph if we wanted to kind of tell us what our values would be for x or y at any given point. But we just went ahead and graphed this equation by using our x and our y-intercepts. Right? Our x and our y-intercepts. There's only one other type of problem that we need to be able to graph, and then we're done with this video. All right, so the next type of lines that we need to be able to graph are vertical lines. All right, so a vertical line is a line going straight up and down vertically. So let me just draw 2 vertical lines really quick. Here's one, a vertical line, and let's draw the other right here. All right, so there are 2 graphs. They are vertical lines. If I look at any point on this green line, there is one point that always remains constant. Our y value here is not the same as our y value here. It's not the same as our y value here. Our y value changes depending on what point we look at. It can go from 0 to 1 to 3 to 4 to 5. It changes as we go along. However, no matter what point I pick, in this point here, we would have an x value of negative 1, 2, 3, 4, 5. So this point here has a value of negative 5, 1, 2, 3, 4, 5, 6, 7, 8, negative 5, 8. This point here has a value of x is still negative 5, and our y value is 1, 2, 3, 4. This point here has a point of negative 5, 0. This point here has a point of negative 5, negative 2. So if you notice, no matter what point I picked, there is a common number that always appears, and that is when our x value is always going to be negative 5. So our vertical lines is when x is equal to some number. In this case, x is equal to negative 5. So if you notice, every single point on this graph that we picked gave us a value of x is equal to negative 5. I'm actually going to erase this one. I'm going to work reverse it next time. So since our x value never changes and it's constant, we can just say x is equal to negative 5. Right? So I can give you then another vertical line to graph, x is equal to 3. So whenever we see x is equal to 3, we will count over 0, 1, 2, 3. I can plot the point here because I know x is equal to 3. And then I need to ask myself, how can I draw this line so that my x value never changes? And if I try to draw it horizontally, our x value changes every single time. So that means it is a vertical line because here our x value, no matter what point we pick, our x value will give us a value of 3. right? I don't say anything about y equal to anything for the vertical lines because our y value is constantly changing. But no matter where we pick a point, our x value everywhere on this red line would be equal to a positive 3. All right, so let's go ahead and do another one real quick. Let's just pick this one. All right, so now we're going to go and do a horizontal line. As I say, I wrote it in blue, so I'll graph it in blue. All right, so let's just pick some points. Let's pick this one here. What is this as an ordered pair? Well, x is equal to -2, and y is equal to positive 2. Let's put this point, our y-intercept. Our x is equal to 0, and our y is equal to positive 2. Let's pick this one. We have 1, 2, 3, 4 for x, and 2 for y. Let's pick this one. We have 6 for x and 2 for y. Just like I asked you with this green graph, what is one thing that never changes? And that is our y value. Our y value never changes. So in this case, we would say that this graph is y is equal to 2. So when we have a y is equal to some number, that generates a horizontal line because our y value can never change. It has to always be the same. All right, so if I give you the graph, y is equal to -3. What you can do first is from our origin, count down 1, 2, 3. Well, there's the point where y is equal to -3. Then ask yourself, how can I draw a graph so that my y value never changes? And since my y value changes moving vertically, that means my graph would have to be drawn horizontally. So I can graph this here at -3 as a horizontal line. And if you see, no matter where I pick this point, my y value will always be -3. And that's how you can test to make sure that you are graphing this correctly. Pick a point on your graph and see, did my y value change? If it did, then it's not done correctly. If it didn't, then you're good. All right, now that is it for this video, and that's it for this section.